My name is Dr. Adrienne Grzenda. I'm a clinical professor of psychiatry and a researcher at the University of California, Los Angeles, and All of You UCLA Medical Center. Today, I will be presenting Ghosts in the Machine Learning. Suicide is a rare but devastating and preventable public health problem. Despite increased awareness and prevention efforts, suicide rates have remained largely unchanged or increased over recent decades. We know that the majority of suicide decedents have contact with a medical provider in the days and weeks before death. A critical window for intervention therefore exists. Predicting suicide, however, has proven a difficult task. This is because there is no single pathway to a suicide attempt. An attempt is the end result of a complex interplay of numerous static, dynamic, and stochastic factors. Suicide risk is not fixed, but changes over time. Predicting suicide is thus a high dimensionality problem. Big high dimensionality data would appear a natural solution, but requires advanced modeling techniques. Machine learning is a branch of artificial intelligence that studies how machines can use algorithms to learn from data to improve performance on a task, like prediction, without explicit programming. The majority of machine learning involves supervised learning, in which the algorithm is supplied with a set of training data which contains the predictors of interest and labeled outcomes. The algorithm then searches for the function that describes the relationship between the two. The trained model can then be applied to new unlabeled data to make predictions. Machine learning models can flexibly integrate large, diverse types of data with minimal assumptions. This would seem ideally suited to the suicide prediction problem. Currently, we are seeing a rapid proliferation of use cases of machine learning, as shown here by the number of publications over time. Machine learning and artificial intelligence are not new. Both fields have experienced repeated patterns of high enthusiasm followed by winters of reduced interest in funding due to often oversold and unfulfilled promises. This begs the question, can machine learning ultimately deliver, or will there always be a ghost in the machine? Machine learning and suicide prediction is currently in its nascent exploratory phase. The next step is the ability to develop a model that can be used in clinical practice, which has yet to occur. Rigor in current machine learning studies is often lacking. At this point in time, as I'll show, we, the human element, are perhaps the biggest threat to machine learning success. If we continue to tumble into methodological pitfalls, progress towards clinical implementation will slow. The optimal fit for a machine learning model balances model complexity and prediction error. A balanced model will rarely have 100% accuracy. There is a tendency to push for the highest prediction accuracy possible by overtuning the model parameters or including too many features. When a model is overfit, the accuracy increases, but in reality, the model is predicting the noise in the data rather than the underlying relationships. When an overfit model is applied to new data, a precipitous drop in accuracy is observed. This is especially problematic given that most machine learning models are not externally validated in a different data set than was used for training. External validation is essential to estimating the reproducibility of the model's behavior in real-world situations. If a model cannot generalize to new data, its clinical utility is effectively zero. A related notion is model portability, or how easily a model can be deployed in other contexts. This is dependent on the number and type of features needed for prediction. If a model requires numerous or expensive data for accuracy, its ability to be validated or achieve implementation are rather limited. Machine learning models can also become overfit unintentionally. One of the most pervasive errors occurs when the model learns information that occurs after the moment of prediction. The model will then perform exceedingly well, like a student who already knows the answers to a test. There can be numerous culprits, many centering on how the data is pre-processed for training by the human operator. Certain predictors may also introduce leakage as inadvertent proxies for the predicted outcome of interest. Machine learning cannot save bad data. Model accuracy and validity are highly dependent on the availability of large amounts of high-quality training data. Differences in demographic coverage, geographic location, clinical setting, and collection methods can negatively influence the representativeness of the training data and the generalizability of the result model. Worse yet, we know that algorithms can inherit other types of bias, such as racial or gender bias. A diagnostic model that does not account for flaws in its training data risks propagating bias and reinforcing disparate care. Much of machine learning research uses structured data, which are data with a clearly defined organizational scheme, such as tables. This type of data requires minimal additional processing for modeling and therefore is highly popular. This means that a lot of machine learning research is using the same data that it always has used, which unsurprisingly can lead to this identification of the same risk factors and results. Unstructured data, by comparison, is everything else: text, images, audio, video. These can require a lot of effort to pre-process, but contain a wealth of information. An estimated 80% of all healthcare data is unstructured data. Alternatively, there are non-clinical unstructured data types, such as social media data, which are proving high yield in suicide prediction. This is to say nothing of emerging data types, such as real-time sensor data. The key to accurate suicide prediction may thus reside in this unexplored unstructured data or in new data types. We cannot be put off by the unknown or the inconvenient. So, will machine learning become accurate enough to duplicate the workings of the human brain? It's too early to tell. Both the humans and the machines are still learning. As Alan Turing, one of the grandfathers of machine learning, noted over 50 years ago, this is only a foretaste of what is to come and only the shadow of what is going to be. We have to have some experience with the machine before we really know its capabilities. Thank you.